Good morning. Thank you for joining me. I'm always happy to see my students, especially in the online virtual classroom. Good morning, Zan. Good morning, Deepan. Okay. That means I type couple of information, but we know everything. Definition of the derivative, then definition of the definite integral. Yes. Addition of infinitely many areas of the rectangle because we are approximating the area under the curve. Definite integral represents the area under the curve if is positive. If the function is negative, we will subtract. Yes, we remember net area. And couple of names, of course, Newton, Isaac Barrow, like we have lots of, Newton and Leibniz, Newton and Leibniz, they discovered the calculus concept almost at the same time, separately. Separately. We did have, if we look at some history, we did have some battle between Newton and Leibniz, but I think now everything is okay. Because people were claiming like who actually is a father of this idea. Okay, I think that's just, and we know that we can approximate by the Riemann sum. We also have a name Riemann, Bernhard Riemann, the German mathematician. But this is mainly like for the finite, we can approximate by the finite number of rectangles. When we add infinity, it's a definition of the integral. Okay, so now what I have? Oh, I have this, we did this, do you remember? We did approximate. I mean, it's not approximation because it's actually a definition, definition of the integral. That means the area was 1/3. We did this one, really nice. That's the way to find the area under the curve. Okay, everything is new. Oh, I need this. Okay, that means first of all, let's look at some settings. Okay? Because we will need for the part 1 and part 2 tomorrow. That means I have function f of t because I'm reserving x for the quantity like the between a and b variable. Just the same thing. That means function f of t at the moment. It's positive, we can see this. It's defined between, it's just defined between a and b. That's we have a and b. And now we know that the area under the curve, area under the curve can be, let's say, f of t dt from a to b. We know this. This is definitely the area under f of t. We know definite integral represents the area. But what I did introduce quantity x, the variable, which vary between a and b, only between a and b. And then I draw it here. Could be any point. We can move it. And that area I call as a new function, g of x. That means g is the area up to x. Like area so far. From a, we can see from a to x. That means this is the definition at the moment, definition of the function g. We definitely know. But now thinking, and the limits are from a to x. And a must be a constant. We have to know where we cannot like vary to. A is like initial point, the lower limit. X, it's a variable. And then when we evaluate this, the answer will depend on x, g of x. But now let's say something about like the concept that we know. What we will do in order to evaluate the integral, definite integral. Do we remember from section 5.2? We just did. We had the velocity. That's we were integrating velocity to get the position function. That means what we're doing, what we really looking, what will be this answer in general? we have to find different synonym for integration. That's what I'm looking for. What's the synonym for integration? Like the integration, it's the anti-differentiation. We like undoing. Yes, that means this is the end. That's the okay. That means g of x. Yeah, for this setting, it's the antiderivative. Yeah? We like if we have all of the information, upper limit, lower limit function, we can anti-differentiate. We can undo the differentiation process. That's the integration. Yeah, that means g of x is the antiderivative. And if g of x is the antiderivative, then I can say that derivative of g will give me back f of x. Yeah, because when I differentiate the answer of the definite integral, I mean integral, then I can get back to the integrand. Yeah, makes sense. Actually, I hope. Let me write something. Do I have? I just want to. No. Oh, yeah. Please tell me that we understand this. Yeah, this was the antiderivative. Okay, that's good. That's me. I don't have to. I can maybe write simple example. Let's say sine of x. What I mean. What's the integral of sine of x? What's the antiderivative of sine of x? Yeah, that will be the antiderivative. Sine of x is just, we always have to think a couple of seconds. I think it's negative cosine of x. Yeah, makes sense? Plus the constant of integration. Okay, that means this is the antiderivative. How do I know? Because when I take this function, negative cosine of x plus the constant c, and differentiate, I will get back sine of x. Yes, that's we can see we're getting back to that integrand. Of course, it's the circle. We undoing and then we can do it again. Yeah, that means integration is the anti-differentiation. That means this one. We have to understand this. Okay. So let's see, because we still have to figure out something, really important thing. Okay. Slowly. Okay, the same thing. That's we know g of x is the antiderivative, and that's how we rewrite this. Okay, that means if the most general antiderivative will have a constant c. So now, what I would like to do, I would like to define something like this. This is still antiderivative. Yeah, the f of x is the antiderivative. That means I would like to check how this can be rewrite in terms of the integral. This is the value of the antiderivative at the endpoints, b minus a. Okay, b minus a. That means let's look at this. The most general antiderivative is g of b plus the constant c, g of a plus the constant c. Yeah, that's what we can see. We have to always add the constant c because the most general antiderivative. Now that difference will eliminate the constant. Yeah, that means this is one thing. When I take the antiderivative for the endpoints, b minus a, then we don't have to be worried for the constant because plus constant minus constant. Now, g of b, okay, g of b, thinking about our settings at the beginning, it's the g of x is the area up to x. Yeah, I can write one more time. It's the antiderivative. That means we're taking this function from a up to x. Then what will be g of b? Will be the area from, yes, up to b. The antiderivative or the area actually of the function f of t dt from a up to b, because that's what, yes, g of x up to x, g of b up to b. And what will be g of a? Can I write here? G of a, based on my settings, my definition, will be also the antiderivative f of t dt from A up to A. And from A up to A, what's the area? What's the integral from A to A? We remember if the limits of integrations are the same, it's 0. Okay, that means now I have just f of A integral from A to B, up to B, the area up to B, and the area up to A, but A, this will be 0. We all understand, okay? That's me now. This is probably it's okay, and we knew it everything. I just put this, but let's see what we've got. That difference, yes, or maybe even the other way, looking at the definite integral. Yes, integral the area of the function f of t dt from A to B, yes. We can, because we don't know still, we know the meaning, yes, we know approximations, we know the limit definition, but now how quickly we can compute. what we need the antiderivative, and we need the difference of the antiderivatives at the endpoints, the values, yes, f of b minus f of a, which if I will ignore the constant, yes, I can say right away g of b, because that was the original g of a. Yes, we can see we can just g is the antiderivative. We need the antiderivative, but then we can just take the value at b minus the value at a, which kind of, I hope, yes, and this will give us the entire area. Yes, yeah. It's something like, I mean, this will be really, really basic, like maybe connection. When we have number line, let's say from 2 to 7, what is number of units between 2 and 7? What we doing, kind of? We just substitute, we just taking the right-hand side value minus the left-hand side. Or you will tell me right away, it's 5, yes? What is number of? We not really like, I know this is probably so obvious, yeah? Number of units between 2 and 7, it's 5. But let's see what we did. We did 7 minus 2, yeah? Respecting all of the Cartesian, all of the perpendicular distances and everything, yeah? That's, we just need the endpoints to find the length of the entire interval, yeah? I'm not like looking and counting, yeah? That means similar to this. This is the area of the under f of t between a and b. That means kind of like I can take the area, if we think the distance from 0, that means the area between a and b. If I will think from distance from 0, that means I'm taking the area kind of like the area to up to b, and then I'm subtracting the area up to a. It's kind of like, yes, from this, yes, from like everything. Let me, I don't want to. Actually, even looking at this, let's say from 2 to 7. Yeah, I mean, you probably, okay, I don't even have to like say, but if I will say, okay, this is, oh, too fast. I will say this is the area up to 7. Yeah, that's, we have to find like, and we know the area in integral antiderivative up to 7, but then I want between 2 and 7, then I will subtract the area up to 2. Kind of like, yeah, we can think 7, 2, we subtracting. Yeah, that's mean it is. We can see g of b, because b will be the upper limit. Let's use 7 and then 2. From 7 and we subtracting 2. It's kind of like, yes, if we think, but of course it's more detailed, and the final, like a bigger picture is, in order to, that's what we have to know, in order to evaluate a definite integral, we just need the antiderivative and the difference between the values at the endpoints, just the endpoints. We don't have to go like the rectangles, and that's the definition, which is still there and really important, but that's yeah, how the definite integral can be computed. Okay, no more explanation. Okay, that means this is part one. In order to get, yes, the definite integral, we will need the antiderivative, of course. F is the antiderivative, and this is antiderivative, and we just need the values at the endpoints of the antiderivative. If thinking that we like subtracting the upper area minus the lower one, we have the area between. That's what integral from a to b f of x dx is. Okay, let's just, yeah, let's evaluate a couple of things, and let's see. One thing. Okay, this is my question. Okay, that's my notes. Let's see what we have to steam now. Yes, I just said this. We just have to subtracting the values of the antiderivative at the endpoints, and that will be the area under the curve, or actually that will be the definite integral. Yeah? That's, we only need 2 points. Yeah? We don't need all of this infinitely many points. And now the notation. And that means we will have the definite integral. Yes, the entire section 5.5.3 definite integral. We will find the formula because we have to have some order, some rigor. We will have the formula antiderivative, and then we will keep, yes, the notation for the limits because we don't want to lose them from a to b. And then we will just substitute b and a, upper limit minus the lower limit. That's it. Let's start. So now I think we know the answer, right? What is the area under the parabola x squared from 0 to 1? We did the long way, the beautiful limit definition. It's 1/3. Thank you. It's 1/3. But now let's see. Yeah, integral will be will be the area because it's positive. Function is also continuous because we have to make sure we remember we cannot accept discontinuity. Then the area is like, we don't know what it is if we have some discontinuity, especially the vertical asymptote. But x squared is positive. I mean continuous function. Okay, that means the process of evaluating this, yeah, unless I will like specify, please use the limit definition. But if it's not specified, we can do as fast as we can. We just need the antiderivative of x squared, and then we will evaluate from 0 to 1. Fundamental Theorem of Calculus. What's the antiderivative for x squared? Yes, x cubed over 3. And let's substitute instead of x. Yes, instead of x. Let's substitute 1, and then let's substitute 0. Always subtraction, yeah? Always think about this. Yes, that means f of b, yes, because a is 0, exactly. Because we're starting from 0. 1/3, yeah, yes, that's nice. Nice process, but we knew it, yes, we knew it. And the proof, yeah, you can check, I will not come back. The proof that I show you, yeah, the difference, it's so, yes, so nice. Okay, let's keep working. 1/3 is the final answer, and that's the area. Instead of using this limit definition, you can also check. My first slide was the limit definition. Okay, how we can just evaluate the integral. Doesn't have to be area. I think I copy, yes. Evaluate the integral from -2 to 1 x cubed dx. Do you think function x cubed is, we have continuity? Is function continuous between -2 and 1? X cubed actually? Yes, it's a polynomial, monomial actually. It's, yeah, continuous everywhere, defined everywhere. That's we have no problem. We can just follow the fundamental theorem of calculus. We need just the antiderivative and evaluate from -2 to 1. Okay, what's the antiderivative for x cubed? Yes, yeah. And we will do the arithmetic, but I mean, arithmetic. Oh, that's, I underestimate this. We have to still know the fundamental theorem of calculus. Yeah, let's see this. I did replace x, all of the x's, yes, all of the variables has to be like evaluating of the function 1 and then lower limit -2. But now it's the arithmetic, because now we have to do, will the answer be negative or positive? I can draw function x cubed, because that's, we may also, it will be negative. Thank you, Zan. And do you think it's correct? From -2 to 1. Yes, it is correct, because let's see the net area. Below, above, we also know this. Because let's look at this. It's easy to make some mistake, but then we know what to expect. Negative part is larger below, yes, then positive, definitely. That's the below, that's above. That's we can make some quick like justification. And let's see, maybe this is 1/4. -2 to the power of 4 will be +16, and that subtraction, that negative will stay. And yes, we do have actually, yeah, -15 quarters. Yeah, negative, correct. That's everything, it's fine. Okay, let's see what else I have. Find the area under the cosine curve. Oh, we have the answer, but let's actually figure out. Under the cosine curve between 0 and pi/2. Oh, before the graph, I supposed to ask you if the cosine is positive, but we can see cosine is positive between 0 and pi/2. Let's just set up the integral, because the area under the curve, or the net area, or the definite integral, yeah, that's this. That's the same. And we need antiderivative. I will not type this. We will get the antiderivative right away, but this is the like a introduction. Okay, what's the antiderivative for cosine? Yeah, we always need a couple of seconds longer to think. It is negative sine of x. Oh, wait. It is negative? That's what I said. I always have to be. Oh, did I type the wrong? No, it's negative or positive. Oh, do you know yes, it's positive. What we can always do, think what you like, what we got, and always differentiate. Sine of x, derivative of sine of x, we will always, we're supposed to get back the original function, original integrand. That means derivative of sine of x, it is cosine, okay? Yeah. But I can tell you, doesn't matter how often I will do this. I always have to think about this trigonometry. Please always differentiate really quickly. And if the derivative works, then because we have lots of practice with derivatives. Okay, sine of x. And now substituting I didn't type. Substituting upper limit minus substituting lower limit. And what is sine at pi/2? That's 0. And that's 1 as expected. The area, yes, thank you. 1 minus 0. You can see how nice it is, but we definitely using this evaluating integral. And we will have the antiderivative minus this. That's really important. Fundamental Theorem of Calculus, part 1. Okay, that's what we have to know from today. When this Kian is, I love this question. I know. Actually, because I didn't discover this, of course. I'm just repeating what they did based on the really hard and long work of this approximation. This is just the result. That's mean this is the result of a couple of lots of years of thinking. I don't want to say hundreds, but yeah, couple of decades of thinking. And that's no. This is, but everything is based on this long way. Without this long way, starting with the approximation and then trying to correct the approximation because it's not good when the number of rectangles is then they discover, okay, this connection. Yeah, but no. It's without the limit and the long way, we will not have these shortcuts. Definition. Oh no, we will use the power rule and all of the rules. Yeah, instead if we know what is the integration and everything. We definitely need some, and I can give you this. I can just say, okay, to evaluate the integral, let's just find antiderivative, and then let's have the difference of but the mathematician, we always want like students to understand where this come from, and especially at the university level. I can always give you a tool and you know how to use it right away. Yeah. Oh, of course, sometimes it's self-explanatory, but why these tools, these formulas works? Yeah. But okay. I know that you are probably, most of my students in the classroom you want just the application, just the tool, and just to apply to your field, to your adventure. Okay, but we know where this come from. Okay, now I have this. I supposed to show you the solution, but we will solve it together. That means if you will see the solution, but what the question is, true or false? How you can actually even the settings. Do you think we can evaluate this integral, definite integral, using the fundamental theorem of calculus? We have function 1 over x squared dx from -1 to 3. That means, can I really, did I type it? I didn't type it. Can I really go the same way? Antiderivative. And what's the antiderivative? We will get this of this from -1 to 3. Yeah, we have to be careful because let's see. That means, what's the antiderivative? Antiderivative, because this is function x to the -2. If we look at the power rule, and now the power rule, okay, that means we will add 1 and add 1. Yes, Deepen, you write -1 over x. That means we will have x to the -1 over -1 between -1 and 3. And let's rewrite a little bit, -1 over x. That's what actually Deepen was telling us, yeah? Because x to the -1 will go to the denominator and negative answer will stay. Okay, and then I can substitute 3, and we have to be really careful. Do you see all of the negatives? -1 over x, -1 over 3, -1 over -1, okay? Then we have negative, it's negative. The final answer actually is negative. Yeah, that's me. We didn't meet on the way to get that answer any problems, algebraic or any problem, but we do have a problem. We do have a problem, and where is the problem? Yeah, I think I'm not even allowed to do this way, but I did it. I will cross this. I will cross this because this, we cannot really, we may use something, but we will learn a little bit in calculus too. At the moment, Fundamental Theorem of Calculus, let's say part 1, is not applicable And why is not applicable? For the function 1 over x squared, 1 over x squared is hyperbola in the, yes, we do have a problem. Oh, it's supposed to be nice and symmetric. We can see between -1 and 3. That's, yeah, what is happening? This function doesn't like what value of x? This function doesn't like 0. We can see we have actually like infinite area in the vertical position. We can still do something. Oh yeah, no, mathematician will not leave this like that. We have some tools, but if you will take calculus too, then then we can talk about this. We call improper integrals, because we do have a problem. But at the moment, fundamental theorem of calculus, it will be we cannot apply because of that. That's mean, please always look at limits of integration. If I will give you limits from 1 to 3, oh, no problem. Yeah, let's look at this one from 1 to 3. That's perfectly fine. That function is continuous. 0 is not in that interval. Perfect. But also, let's look at this negative. Do you think negative value, we didn't make any mistake. That means this is arithmetically, algebraically correct. Do you think negative answer makes sense? For positive function, function is placed above the x-axis. Yeah, the answer is supposed to be negative. But yes, we've got negative. That means something is definitely wrong. Yeah, that's not, doesn't make sense, negative, because we suppose everything is above the x-axis, but we do have a problem. That means this is, that's false. That's false. We cannot really evaluate this. But I know now you will pay attention and you will know. Then you will say, no, we cannot apply fundamental theorem of calculus for these limits of integration for that function. Okay, and then I think I have it. Let me skip this for a second. Let's look at this one. Yeah, that's actually, and I have the, oh, I thought that it's okay. Okay, that's mean, let's look at, I have 1, 2, 3, and 4. 1 over x. That means a, let's leave it a for a second, but number 2. Do you think we can apply fundamental theorem of calculus for number 2? One over x. Function 1 over x is hyperbola in the first and the third quadrant. Also, this function is not defined at 0. Similar, for this one we can get negatives. That's different, but because function is negative for the negative x's. But between 2, I think yes, between 2 and 8, 0 is not this. That means fundamental theorem of calculus part 1, it's fine. What about between 1 and e? This one. Fundamental theorem of calculus part 1, I think it's possible. What about between -4 and -2? I think it's okay, because 0, we just have to look at 0. Yes, if -4 to 2, yes, if 0 is not in that interval, then we're fine. We're perfectly fine. This is actually this one. Between -4, this one is between 1 and e, and this one is between 2 and 8. Okay, everything, yes, everything what like with any intervals without like 0 inside, it's fine. Okay, but now let's actually do number 1 as a general. Where is the, because I can't write. What is the antiderivative for 1 over x? Because it's x to the -1. Yes, we will have different. And please remember, we do have we do have absolute value. Yes, and then we will somebody can type plus the constant c. It's fine, but we remember plus the constant c, we will subtract, they will be gone. That means for the definite integral, we don't have to, we can put this, yeah, but it will be adding, subtracting, it will be gone. But yeah, it's fine. Natural log of b plus c minus c, that's a natural log of a. And yes, when we subtracting, we may divide. That means this is the answer. We don't have to memorize. Oh no, not at all. But we have to know the antiderivative for 1 over x. Natural log of b minus a. Okay, that means this is, I can actually say right away, between 2 and 8, natural log of 8, natural log of 2. I don't need absolute value because they are positive. Natural log at 4. Yeah? And this one, natural log of e over 1. What's the natural log of e? Natural log of e is actually 1. And this one will be natural log of -2 over -4. Let's put absolute value, which, however, it will be positive. Okay, that's the final answer. Yes, yeah, okay. Okay, that means just to remember about this continuity. Okay, and then I think I skip. Okay, what about this one? Because I have to also mention something. Yeah, we're just practicing the integration, anti-differentiation. We have integral from 0 to 2, x times 2 plus x to the power of 4 dx. Polynomial definitely defined for all of the numbers. That means x could be any real number. We have no problem. We have continuity. That means we're fine with this. But how we can start this question? Oh, Deepan, you have to answer. You amazing. Let's see if this is the answer, because I have a really important message at the moment. Yes, at this point. What we see, first of all, we see product, x times. That means, please, yes, we do not, oh no, x could be 0. X could be 0. We have no problem because this is polynomial. It's defined everywhere. Yeah, it's fine. Yeah, it's fine. But what is my message? The main message: if we see a product or quotient at this point, and if we're looking at this product and it's product of the same function, we have to avoid the product. We have to do something. Sometimes we cannot avoid. We have to use different tools, but that will be next week. But at this point, we don't know, because you remember, like for differentiation, do you remember these big formulas, product rule, quotient rule? Not even mentioning chain rule, like all of the other. Now we have to try to reverse them. We still don't know. That's a little bit harder problem. Harder like concept. But that means we cannot definitely we will not like integrate this, and integrate this. No. Because the integral of the product is not product of the integrals, the same like for differentiation. But this one is not a problem because I can avoid this product right away. Yes. And we know now when it's addition or subtraction, no problem. Addition of the integration is the other way. Integration of the addition is the addition of two integrals. We can just integrate term by term if we have expanded form, addition, subtraction. Yes, when we have a product, we have to be really careful. Please remember, actually this is, we have to avoid. Sometimes, like for instance, x times sine of x. Do you think we can avoid product x times sine of x? No, because two different functions. Yeah, it's not two algebraic function. I cannot. That means this one is actually, I think it's Mat 141. Okay, Mat 141. We will do something similar next week, but something different. This one we need different tool. Yeah, because we have to kind of like, yeah, look at the product rule and maybe try to reverse the product rule. Okay, but let's do this one. Please tell me the antiderivatives. What's the antiderivative for 2x? Yeah, good practice, good practice. It's, let me just, okay. Yeah, x squared. What's the antiderivative for x to the power of 5? X to the power of 6 over 6. And now, because sometimes we have this mistake, both of the x's we have to replace with 2, and then minus both of the x's we have to replace with the lower limit, 0. Sometimes we will put 2 and 0 for both. Yeah, that's we have to say 2 to the power of 2, 2 to the power of 6 over 6, upper limit, yes, f of b, minus 0, which 0 is funny. But let me write down. Yeah, that will be just 0. But please do not put 2 and 0, like 1x will be upper limit, 1x will be lower limit. No, sometimes I saw these mistakes a couple of times. Okay, 4 plus, that's what, yes, that's what Deepan said. 2 to the power of 6, it is 64. It is 64. 16, 32, and 64, okay. 32 over 3, 12, 44 over 3. I hope I did the right math. I mean arithmetic. Yes, but we can see that's the, yes, the avoid the product. Okay. It is 44. Okay. Now let's see. Now the similar situation. We see a quotient. Yeah. Please do not integrate like that term, and that term. Oh, no. We also need some tools if we would like to deal directly with the quotient. But if we can avoid, yes, oh, definitely. Actually, let's check. This function is not defined before I do the algebra. It's not defined for what x? We do for x 0. But do we have a problem on our interval? No, that's mean we good. We good. We don't have to like, yeah, we can apply the fundamental theorem of calculus. Yeah, that's mean I will split for this. Yeah, if we have one, that's 9 actually. If we have one quantity in the denominator, nice and easy. Okay, that's mean from 1 to 9, x over square root of x is x to the power of what number? 1 minus 1/2. 1/2. Am I right? This one will be negative half. Please tell me that we okay with this. Do we see negative? I just want to negative 1/2. Because this is x to the power of 1, x to the power of 1/2 in the denominator, the same base, division, we're subtracting the exponent. Okay, and now we can just evaluate. Please tell me what's the integral of x to the 1/2. Oh, we have a fractions. We adding 1, right? 3/2 and 3/2. Oh yes, 2/3. And this one will be 1/2 and dividing by 1/2. We don't need constant c because we know that they will cancel out. Okay, that means this one is 2/3 square root of x cube. This one is 2 square root of x. Yeah, just different form when we evaluating, it's helpful. Power form is good for next, like yeah, sum up some formulas and power rule, quotient rule. Okay, now let's quickly, do we have time? Because I have a couple of more. When we put square root of 9 cube, and now let's see square root of 9. Yes, we have to substitute, replace all of the variable with the upper limit and all of the variable with the lower limit. Cube and 1. I hope I did correctly because x to the power of 3/2 is the square root cube. Square root of 9. Deepen, you have your calculation. Square root of 9, it's 3. 3 to the power of 3 is 27. 27 divided by 3 is 9. 18. Yes, you have 18. Minus 6, because it's yes. Okay. And this one will be 2/3, and my negative, subtracting negative 2. Okay. And what it is? It is 40 over 3. 12, 14. That means it will be 14 plus, actually minus 14 minus 2/3, which is 13 and 1/3. 39, 40 over 3. Perfect, perfect. Okay. But this is, yeah, that's important. And fundamental theorem of calculus, part 1. Yeah? Substituting the upper and the lower limit. Okay, we know how to deal with the product quotient. Oh yeah, you can do this one, no problem. We did this because you can do, what integral you will set up? Find the area of the region under the curve e to the x minus x between 1 and 2. Just this. Yes, just the integral of this. And let's maybe get the antiderivative. We have no problem. E to the x is defined for all of the numbers. X is defined for all of the numbers. No problem, definitely. And I think it's a positive function. I don't know exactly how function looks like, but okay, that means antiderivative for e to the x is just e to the x. And this for x is x squared over 2. And what's the final answer? E squared minus 2. Am I right? E minus 1/2. So we have e squared minus e minus 3/2, if I am right. It's definitely, yes, it's a positive number. Okay, nice. I was testing the antiderivative formulas. And then I have a couple of practice problems, but you can do them. I think we have no problem. This is 0 is not, and this one you can do. But I have, okay, I have this integral, this one. Oh, okay. I mean, we can do the last one. Let's do this and this, the absolute value, okay? Because I think the similar we have on the homework assignment, and we will be done. 2 more integrals. Okay, that means absolute value is always positive. This is from 0 to 9. Yeah? Integral of 7, my absolute value of the quantity 7 minus x dx. That's what we can do. We have a little bit longer way to deal with the absolute value because we have to, function is different. I mean, if we rewrite without the absolute value. Like when we rewrite without the absolute value, we may, because the quantity inside could be positive, negative. That means this affects the whole calculation. But this question, since I see like a linear function, just the line, linear function inside. Let's look at my next question. Next question has x squared. That means that's different. And that's a little bit, we will do the proper way. But this one, I would like to show you the shortcut, which you probably watch my video, how we can evaluate the integrals using just the areas. Directly, triangles, rectangles, circles. I hope you watch this. It's so helpful. That's me. What I can do. I would like to investigate how this function looks like, and let's see what shape we're dealing with. Absolute value of x minus 7. It's minus. That's we have to be careful. Okay, do we know how? I was just thinking how we can get the graph. Okay, let's maybe do this way. Am I actually, no, we have no, let's because it's absolute value, right? What's the zero? We know how absolute value looks like. Yes. Oh, actually, maybe we can say 7 minus x and 7 minus x. What is the zero? Yes, it's definitely the v. Definitely the v. Because I can draw it. You can probably draw it, but let's if, yes, that means definitely 7. 7 is the magic number, which this will be where the v is attached. Yeah? That means I hope we can draw the graph like this. But what we can do, 7 minus x, if the quantity 7 minus x is positive, then I can ignore absolute value. That means this will be this graph. But what I can say, this must be positive. Yeah? If the quantity 7 minus x is negative, then this quantity will become, this will be negative, then I have to make it positive. Yeah? That's how we normally do the definition. If x is positive, we can ignore it, absolute value. If the quantity is negative, then we make it positive. Yeah, that means this is the definition. Yeah, important. That means this, for what values of x, I can subtract 7. That means x is less than 7. For all of the x's less than 7, yes, less than 7, we will have that function, 7 minus x. And 7 minus x is this function. Negative slope, x-intercept 7, y-intercept also 7. Yeah? But we only accepting that line for x is less than 7. That means we only accepting this part. Yes, that's how we can properly get this. Okay, now, if x is less than 7, then I can solve this inequality. This is the domain. For x is greater than 7, we will have that line. When I distribute negative, we will have x minus 7. Line x minus 7 looks like this. But we only accepting for positive x's. I mean not for positive, greater than 7, which greater than 7 starts here. Okay, that means that's how the v, that's how we create the v. That's where the v come from. Okay, and what is my point? My point is when we see the straight line, yes, the absolute value, we may look at the limits from 0, because this is our function. This is the function, absolute value of 7 minus x. We integrating this between 0 and 9. Let's see what shapes we have between 0 and 7 and between 7 and 9. Yeah, because we do have 2 triangles. That we can just add the area of the first one and the area of the second one. And that's it. Okay, let's write this. Actually, I can write maybe here. What's the area of the first triangle? Yeah, 1/2 times base times height. 1/2 base is 7. Yes, thank you, Kian. And height is also 7. 49 over 2. And then everything is positive. We adding the second one. The second one is also triangle. 1/2 times base times height. What's the base for the second one? How many units between 7 and 9? 2. Yes. Yeah. And then what's the height? What's the value of the function for 9? When we substitute 9, 7 minus 9, it's -2, but absolute value of -2 is +2. Okay, that means this one is actually 2. So we will just add 49 over 2 plus 2 for 53 over 2. Okay, that means this, yeah, this is one way to do this. One way, especially when we have a straight line. But if we would like to go through the antiderivatives, which we have to go the next, yeah, then we will use the formulas, which actually it will be that formula. Okay, that formula will be for all of the x's. I mean, we can create the integrals. 7 minus x without the absolute value for all of the x's less than 7, meaning from 0 to 7, because 0 was the lower limit. Yes, I can't say from negative infinity, from 0 to 7. Now, that means you will evaluate this and you will get 49 over 2, because we got through the triangle. This integral for all of the x's greater than 7, from 7 to 9, because we had a limitation 9, we will integrate that formula. Do you see the difference? And you will get 2. And then we will add them together. That means always for the absolute value, we will end up with 2 or even more integrals, because we have to find out where the function is positive, then we're not changing the formula. Where the function is negative, then we're changing the formula for the positive, adding extra negative in front of the entire expression. Right? That means both of these blue integrals will give you that answer, but we use the shortcut. Let's do, okay, or maybe we can do it tomorrow, because tomorrow we will have a second part. We will have different, because I don't want to keep you longer. You can try, but definitely we have to figure out first, we will split for 2 integrals. Because we can see x squared minus 4. I don't know if we know how the function looks like, but we have to figure out, yes, where this quantity is positive. That means this quantity is positive or equals to 0, or if this quantity is negative, then we will change the formula. We can see it will be 4 minus x squared. Yeah? And then we will have, consequently, we will have an integral of x squared minus 4, but we need the limits. We need the limits of integration. Let's say a, b. And then we will integrate that formula, 4, yeah? We switch 4 minus x squared, but we need also the limits. Let's say c and d. And that number will give us, but finding the limits all depend from 0 to 2 is positive and from 2 to 9 is negative, or the other way. We can just we can x squared minus 4. We don't even have to solve this quadratic inequality. What's the shape of the function, quadratic function? Parabola. And this is x squared, parabola, yes, shifted 4 units down. Perfect. I mean, this is 4, this is 2 and 2. I mean negative, of course. Okay, that's we may see where is negative. Negative is here. Yeah, this is just inside function, of course. That means from 0 to 2. X is from 0 to 2. From 0 to 2. But that part was negative. That means I have to change it. It will be flipped. Okay, and what about where this is positive? Let's say from 2 to 9, because we have to stop at 9. Oh, it's a little bit bigger, because we have the limit 9. Yeah, it means from 2 to 9. Okay. Now you can definitely